Hi everyone, today we are going to start 4.5, which is prove triangles congruent by side angle side and hypotenuse leg. So once again, these are all the things that you must have to be able to prove triangles are congruent. Yesterday we talked about side, side, side. In this lesson, we're going to talk about side, angle side, and hypotenuse leg. Side, angle, side, congruent postulate. If two sides of an included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So if we look at our diagram here, we notice that this side is congruent to this side because I have two tick marks. This angle is congruent to this angle, and this side is congruent to this side, and I see that because of one tick mark. So this is side, angle, side. All right, so our first example here is a proof. So we want to prove that triangle ABC is congruent to triangle CDA. Now what's given is that segment BC is congruent to segment DA, and segment BC is parallel to segment AD. All right, so what's the first thing we write down in our proof? It's going to be what is given. So I'm given that BC is congruent to segment DA, and that is given. And now in my diagram, I'm going to look at those markings. So this segment is congruent to this segment. And secondly, we know that BC is not congruent, but parallel to segment AD. And that was also given. And that's what these arrows mean. All right, so next we need to figure out, being parallel, we have alternate interior angles. So which angles, knowing that these two lines are parallel, do we have that are congruent? Well, this angle here and this angle here are congruent. And I'm going to write this down. So angle BCA is congruent to angle DAC, and why? Those are alternate interior angles. All right, so right now I have a side and an angle for both of my triangles, and I need to find another side. Well, if I look at my diagram, I notice that both triangles share the side AC. So I'm going to mark this. And so now I need to write this out. So I have segment AC is congruent to segment AC. What property is that? That is the reflexive property. And so now I am done, and I can say what I just proved. So I just proved that triangle ABC is congruent to triangle CDA, and my reasoning is side, angle, side. Example 2. In the diagram, QS and RP pass through the center M of the circle. What can we conclude about triangle MSR and triangle NPQ? All right, so there's a few things. We know that M is the center, which means if M is in the center, it's going to cut SQ in half. So those two segments are then congruent. It's going to do the same thing with RP, meaning that these two segments are congruent. And there's one more thing looking at this diagram that I can say are congruent. These two angles. Why? What type of angles are those? They're vertical angles. So now looking at my diagram, I see I have a side, an angle, and a side for both of those triangles that are congruent. So therefore, triangle MRS is congruent to triangle MPQ because of side angle side theorem. Now we want to watch out for side angle. So in general, if you know two lengths of two sides, and then in the measure of the angle that is not included in between them, you create two different triangles. So side angle side is not one of our congruent theorems. So, and if you look here, these are side angle, but two triangles could be created, which would be this blue segment. That's why it does not work. These two triangles, this one here and this one here, are not congruent. They're different shapes. So this is why side angle is not valid. Now, to me, this is very easy to see because side angle, if you flip it around, it's a bad word, right? So anytime you see that word, we know right away that it's not a congruent statement. It's not going to work. Lastly, the hypotenuse leg congruence theorem. If the hypotenuse and a leg of a right triangle, this only works for a right triangle, are congruent, then the hypotenuse and the leg of the second right triangle, then the two triangles are congruent. All right, so let's use the hypotenuse leg congruent postulate. We want to write a proof. So we are given that segment WY is congruent to segment XZ. WZ is perpendicular to segment ZY, and XY is perpendicular to ZY. We want to prove that these two triangles are congruent. Now, if I look at this diagram, I have two triangles that are kind of overlapping. So I'm actually going to redraw this so I can see the two separate triangles. So I have a triangle here. I'm going to outline it in purple. So I'm going to draw a bad sketch of the triangle here, and this is W, Z, Y. And now I'm going to sketch out the other triangle in blue, and I'm going to sketch that out over here. And this is Z, Y, X. All right, so with our proof, the first thing we always write is the given. So 1, we are given that WY is congruent to XZ. Okay, and my reason, that was given. So I am going to then sketch that out. So WY is here, and XZ is right here. Okay. Number 2, I'm also told that WZ is perpendicular to ZY, and XY is perpendicular to ZY. This was also given. So that means that these two angles here are perpendicular, 90 degrees. All right, and then lastly, if I look at my original diagram here, do you notice that both of these triangles share a side? What side do they share? This side right here, ZY. So I can mark that. I need to make sure that I write that in my proof. So 3, I know that ZY is congruent to ZY. And what's my reasoning? The reflexive property. And so now I have two right triangles. I know that the hypotenuse are the same. I know that I have a leg that is the same. So therefore, these two triangles are congruent. So triangle WYZ is congruent to triangle XZY, y by the hypotenuse leg theorem.